Now that we've chopped out the portion of the building that we want to fracture and cashed out both that and the static section, we can move on to finally run our full detailed fracture on this. So I'm going to jump out of this prep section here and we'll create a new section. I'll call this week 2 _ fracture building. Then we'll dive in there and object merge in our section that we want to fracture. We'll pull that from object week 2 prep, and that was called out to fracture. Now, one optional step that can sometimes be handy later on in the process is to create a name orig attribute that will match what the current name is, so when we run a detailed fracture on this, we can tell where every little individual piece came from. So to create that attribute, just drop in a primitive wrangle. I'll call this set name orig, connect the object merge to that, and in our vex code we'll type s at name _ orig equals s at name. And then if we check our spreadsheet, you'll see we now have a name orig attribute that matches our original name. Another optional step is to use our measure fracture node to remove some of the tiny pieces that we don't want to run an extra fracture on, or maybe don't want to include in the shot whatsoever. So if you drop in that measure fracture, that will default to calculating the bounding box size. And I'll turn on my bounding box filter. Let's set that down to maybe 0.01. And maybe some of those pieces are still a little bit too big to remove. So maybe I'll go a little bit lower. We'll try 0.05. Actually, let's make that 0.005. And this is looking pretty reasonable. Some of these little pieces here don't look too small, but they're probably embedded inside the building. Looks like those are not near the exterior, so we don't have to worry too much about removing pieces that are not immediately visible on the overall surface of that building. And now to run the detailed fracture, we're going to do it section by section. It gives us a bit more control than running one fracture on this entire thing all at once, and we might want different amounts of detail on the exterior versus the interior versus the window frames, and etc. So I'll just create a null here, connect it to the second output of our measure fracture, call this fracture. Now we can use a few split nodes to define each fracture region of the building. So for the first one, drop in that split, and we'll write in the group at path equals star interior star. See, that isolates our interior section for us, and we'll name everything as such, and we'll drop in another split node for the window frames. Put the second input of the first one into that. We'll call this window frames. And for this one, I'm going to use the name attribute. We'll say at name equals window star to just isolate those frames. And then whatever's left over should be the exterior of our building. So I'll just create a null, connect that second output of the split, and call this exterior. Now the workflow for running these fractures is essentially the same as what we set up in week 1. So we'll drop in a cutter geometry node and connect our exterior to that. I tend to like starting with a very low number of cutters. We'll increase the resolution to 300, turn off the small noise amplitude, and some of these default settings were created in the context of a pretty large scale scene. So you might want to set some of these defaults to be a bit lower in your version of the tool, because I'm finding myself needing to lower a lot of these noise amplitudes and sizes by roughly a factor of 10. So maybe I'll change that large noise size to 10 and the amplitude to 20, and we can see what that looks like. And you can see that this looks like some pretty weird curly geometry, and that can be okay. But I mentioned in week 1 that I had previously set this up with a mountain node. And I really do like the attribute noise for a lot of things, but I'm not very happy with the results that I'm getting with it in this context. If I reduce the number of cutters to just a couple, you can see that when you really push this particular attribute noise, it starts to fold on itself quite a bit. Whereas if we just use the mountain SOP or the displace along normal, when you push those values hard, it'll just do something like this without folding in like this attribute noise is. So let's go in and modify our cutter geometry tool to use a displace along normal instead. So I'm going to right click on this and allow editing of contents. And then we can dive inside and go to this low frequency attribute noise here. Now we can disconnect this amplitude control from that. Maybe control middle click that to set it back to default. And we can still use this attribute noise here to set up a noise value for our displacement amount, but we want the amplitude to be controlled in that actual displace node, not in this attribute noise node. Now we're also not going to use this anymore to change the P position. We're going to instead generate a noise attribute, and we can set that to be a one-dimensional attribute because we don't need this noise displacement amount to be a vector. It'll displace along the normal vector of the surface, but the actual noise amount can just be a one-dimensional value. Now let's type in VOP to create a point VOP, and we'll connect our low frequency noise to that, and we can display that and dive inside, and we'll create a displace along normal node. Then you can connect your P to that and the displaced P to the position output, and then we'll use a bind to bring in that noise attribute that we've set up and connect that to the amount of our displacement here. Now in the bind, just type noise into the name parameter there, and you can see it's starting to pick up those noise values that we set up from this attribute noise here. Now this is just a very small amount of displacement so far because this is not yet linked to the control on the cutter geometry. So I'll copy that parameter for the large noise amplitude and dive back inside, and you can directly paste the reference into this displace along normal node, or if you want to, you can promote that parameter so that it's available outside the VOP network on this point VOP here, and sometimes it's nicer to work with attributes that way so you don't always have to dive inside the VOP net to change some of your common controls. It's kind of personal preference depending on the setup. Now I'll paste the relative reference into that scale, so this displacement amount is controlled by the tool as we expect. And we can connect this point VOP output to this attribute delete here. And then on our attribute delete, we can get rid of that noise attribute because we no longer need it. Now if we exit the tool, we can test out this new version of our low frequency kind of broad detail noise. Let me bring a few more cutters back into this. Maybe let's bring it back up to 5 cutters, and we'll turn on this trim outside object. And this looks like it's creating much nicer shapes for that sort of low frequency noise on our cutter geometry. Before I save this new version of the cutter geometry HDA, I'm going to go to my OTLs directory and just do a quick backup of my HDA file. You can come up with your own methods of version control if you'd like, and I'm sure there's software out there that can assist with this. But just for a quick backup of that, I'm just going to right click my HDA file and add it to a RAR or a zip file, and just maybe call this backup 01, just in case we ever need to revert to that. So now I will save this node type and tell it to match the current definition. And then we can continue designing our cutters with our new and improved tool.